if a task ends with one answer. Ordinary Gemini may be enough. If it must keep moving through connected apps on a schedule with review checkpoints, Gemini Spark is a different kind of work surface.
Right.
And if the proof you need is a repository diff and passing tests, route the task to Codex or Claude Code instead.
Right.
I promise you today we're going to actually map out a sanitized weekday public update brief that transforms into a fully cited digest complete with like a strict human review checklist, AI Everyday Lab, route the task to Spark, Gemini, Codex, or Claude Code.
Yeah.
So welcome to this deep dive. I am really thrilled you are joining us today because we're tackling what might just be the most fundamental shift in how we interact with software. Well, really since the smartphone.
Definitely.
We're moving completely past this era of the simple chatbot. Like that paradigm is just over.
Yeah, it's done.
Right. We're entering the era of specialized agentic work surfaces. But before we get into the actual architecture of how you build these workflows, we really have to lay down some non-negotiable ground rules about what we are and what we are not doing today.
Yeah, this is so important. It is absolutely crucial to state up front that if you want to use Gemini Spark, its availability, your region, your platform, your subscription, your language, and your connected app access must all be verified in your own account.
Right, because it's so locked down right now.
Exactly. We also have to be incredibly clear with you. We are not claiming that Spark, Ordinary Gemini, or Claude Code was live tested here today.
Right, no live demos here.
No, all the guidance we're giving is based strictly on official source documentation and verified local dummy runs where we explicitly note them.
Yeah.
We are giving you the map based on official blueprints, but you have to check your own terrain.
Right, we are giving you the map so you can navigate that terrain safely. So let's start with a major routing mistake that honestly almost everyone makes when they first get their hands on these tools.
A chatbot habit.
Yes, exactly. The viewer problem here is that we've all been trained really since about late 2022 to treat every single AI tool as a fundamentally interchangeable chat window.
Right, just a text box.
You open a text box, you type a prompt, you get an answer. But treating these new systems as interchangeable chat boxes leads to this massive routing mistake.
It breaks the whole workflow.
Yeah, we try to force a simple answer engine to do, like complex scheduling, or even worse, we ask an ongoing background agent to write raw, isolated code for our software repository.
Which is a profound misunderstanding of what these tools are actually built to do.
Right.
If you treat an agent like a chatbot, it's going to fail. To solve this, you have to stop looking at the brand names, You have to start looking at 3 distinct proof objects that should guide your routing decisions.
Okay, proof object.
Yeah. The first proof object is a task brief, like the weekday update brief we're going to build today.
Right.
The second is a schedule and review boundary. And the third is a code diff and a test report. These objects dictate the underlying mechanism you have to use.
Okay, let me pause you right there. When you say proof objects, you mean like the actual output we need to verify the job was done right?
Well, not just the output, but the container of the work.
Oh, okay.
And to get that right, you need to separate your mental model into 3 completely distinct execution surfaces.
Lay them out for us.
First, you have an answer surface.
Right.
This is for your turn-by-turn, one-off conversations. You ask a question, it answers, the session ends.
Like a normal search.
Exactly.
Okay.
Second, you have an ongoing connected workflow surface.
Okay, and that's different because...
Because it's for tasks that span across different apps and operate over time, even when you aren't actively sitting at your keyboard typing.
Wow, okay.
And third, you have a repository or terminal execution surface.
Right, the coding stuff.
Yes. This is for deep multi-file code execution where you need access to your local machine or like a highly specific sandboxed coding environment.
It really makes me think of how we organize a physical kitchen.
Oh, I like this.
Yeah, like you wouldn't use a slow cooker to chop an onion.
Right.
I mean, they both ultimately help you make dinner, but they operate on totally different surfaces and over completely different time horizons.
Exactly.
A slow cooker is that ongoing background process. You said it. It runs for 6 hours while you go do other things. A chef's knife is your immediate one-off execution.
Yeah.
If you try to chop vegetables with a slow cooker, you just get a mess.
That is a perfect analogy. And the practical value for you listening right now is that you must learn to choose your tool based on the work surface required, not the brand name.
Because the branding is so confusing right now.
It is incredibly blurry. I mean, we have Gemini, Gemini Spark, Codex, Copilot, Claude, Claude Code.
It's all just thrown together.
Right. If you just look at the brand, you will route the task wrong. You have to look at where the work actually lives and how it executes over time.
Which means we really need to talk about what it actually looks like to use that slow cooker, the ongoing connected workflow surface.
Right, Gemini Spark.
Because automating a recurring workflow across your apps sounds amazing, but I mean, it also sounds terrifying if you give an AI unchecked autonomy.
It can be.
We've all read the disaster stories of AI agents hallucinating and sending bizarre emails to entire client lists.
And that is the exact viewer problem we have to solve today. How to safely automate a recurring workflow across apps without giving an AI dangerous, unchecked autonomy.
So how do we do that?
Let's look at our proof artifact to really ground this. We are going to use a sanitized weekday public update brief.
Okay.
If you were building this, the instruction you write would look exactly like this. Quote, every weekday at 8:30, gather 3 official updates about a named public topic, cite the source URLs, put them in a short digest, and ask for review before any email or file change. Unquote.
Man, let me break that down, because every single clause in that prompt feels so intentional.
It is.
You didn't just say, like, give me the news every morning.
Right, because every word is a constraint. Let's look at the mechanism for using Spark safely to actually achieve this.
Okay, step 1.
The very first step, before you even write that prompt, is checking your eligibility.
Because it's not just everywhere yet.
Exactly. Spark is not just a button everyone suddenly has on their dashboard. According to Google's official documentation, you must be 18 or older.
Okay.
You must be using a personal Google account, not a work or school workspace account.
Wait, really?
Yes. And you need an eligible Google AI subscription, like the Ultra or Pro tiers.
Wow, okay.
On top of that, you must have your Keep Activity settings enabled.
Hold on, let me just clarify. So if I'm listening to this at work and I have a massive enterprise Google Workspace account, I can't use this.
Correct. Not on that account.
And what about the regional restrictions? Because I remember seeing a lot of fine print about where this is actually live.
You're totally right to push back on that because the rollout is a massive patchwork quilt.
Yeah.
Initially, the Mac beta was US only. Then it expanded for Pro subscribers to over 160 countries.
Well, that's good.
And this is but they explicitly block the European Economic Area, Nigeria, Switzerland, and the UK.
Oh, wow.
So if you are listening from London, Berlin, or Lagos, you cannot currently run this workflow. It is geo-blocked right at the account level.
That is wild. So they are being incredibly cautious with this rollout.
Very.
I guess likely because of regulatory concerns and just the sheer power of a background agent.
Absolutely.
But let's say I am in a supported region. I have a personal Pro account. I pass all the checks. I've got my tool. What's the next step to, not accidentally let this thing run wild?
You write a bounded goal. You use the exact sanitized weekday brief we just outlined.
Right.
Notice the word sanitized. You must use sanitized public inputs for a task like this.
But no company secrets.
You never, ever use sensitive data, personal passwords, or confidential client information to test a new agent.
Just don't do it.
Exactly. If the topic you are tracking is global supply chain logistics, great. If the topic is my company's internal Q3 financial vulnerability report, absolutely not.
Right, because this thing's going to be running in the background, interacting with other software.
Yes.
Speaking of which, how does it actually talk to other apps? Because a digest isn't very useful if it just lives inside the AI's own memory.
Right, and this is where we specify the allowed connected apps or skills. Spark doesn't just guess what apps it can use. You must grant explicit permission.
Okay, how?
It connects to Google Workspace, Google Tasks, Keep, and third-party apps via something called the Model Context Protocol, or MCP.
Okay, wait, stop right there.
Yeah.
MCP, Model Context Protocol. That sounds like heavy enterprise developer jargon.
It does, yeah.
What is the AI actually doing when it uses MCP? Is it just an API?
That's a great question because it's actually much more than a traditional API.
Okay.
Historically, if you wanted an AI to talk to Dropbox, developers had to write custom, brittle integrations for every single app.
Great all the time.
Right. If the API changed, the AI broke. The Model Context Protocol is an open standard that standardizes how AI models access data across different sources. Think of it like a universal translator. Instead of Spark needing to learn the specific language of Canva and the specific language of Dropbox, MCP provides this standardized context window.
Oh, well, that makes sense.
The app exposes its data safely through an MCP server, and Spark reads it. The official docs list connections to platforms like Canva, Keep, Workspace.
But it only works if you allow it, right?
Exactly. You, the user, must specify those allowed connections.
Got it. So it's a standardized bridge. I tell it to use the bridge to Workspace. I tell it to pull 3 official updates. But, AI still hallucinates.
It certainly does.
How do I know the digest it builds isn't just creative fiction?
You demand proof within the prompt itself. You require source URLs and dates.
Wow.
By forcing the agent to append the exact URL it retrieved the data from, you create an audit trail.
And then comes the golden rule of any automation.
Yes. You test it once before you set it to recur.
Always.
You do not set a daily 8:30 a.m. schedule on your first try. You run it manually. You verify the output.
Right.
And this is the most critical safety mechanism of all. You require approval.
The checkpoints.
You must mandate a human checkpoint before the agent takes any external action.
So like sending an email.
Right. Before it sends an email, before it moves a file, before it archives a document, or before it unsubscribes you from a list, it must stop and ask you for permission.
Let me challenge this entire concept, though.
Okay, go ahead.
Isn't an always-on agent inherently risky? I mean, even with a checkpoint, it feels a little like leaving the stove on when you leave the house.
I get that.
It's running on Google's cloud 24/7. It's active while I'm literally asleep.
It is a highly valid concern, and it's exactly why we have to deeply understand the architecture of a workflow surface.
Break it down for me.
What makes this a workflow surface is precisely that connected context and the 24/7 cloud schedule.
Because it's not on my local machine.
Right. It doesn't rely on your laptop being open. It lives in Google's infrastructure. But that mandatory human review checkpoint acts as the physical shutoff valve on your stove.
Oh, I see.
The agent can prep the ingredients, it can put them in the pan, it can even turn the dial, but the gas does not flow until you physically push the approval button.
That's a great way to put it.
It fundamentally changes the risk profile from autonomous action to autonomous preparation.
Which is much safer.
Much safer. But again, just as a deeper note, we cannot promise access to every account due to that staged rollout we talked about earlier.
Right. So setting up these checkpoints, writing these highly bounded goals, checking all these MCP app permissions, it requires a lot of cognitive effort.
It does.
It's basically building a safety cage, which really makes me wonder, if I don't need a safety cage, am I just overcomplicating things?
And that is the perfect transition to our next viewer problem.
Yeah.
We often overcomplicate a simple single-answer task by forcing it into a complex, scheduled workflow agent. We just get caught up in the shiny new object syndrome.
Right. Like if I just want a summary of today's news right now, I don't need a background agent scheduling an MCP connection to my inbox.
Exactly. To prove this, let's look at the artifact for ordinary Gemini.
Okay.
Imagine running that exact same weekday update brief, gathering 3 official updates about a named topic, but you run it as a one-off, turn-by-turn conversation in ordinary Gemini.
So what is the actual mechanism difference there? Because to the average user, they are both just a Google text box with a little sparkle icon.
The difference is the underlying work surface. Ordinary Gemini operates purely as an answer surface.
Okay, an answer surface.
You provide the instruction and it gives you a single answer right then and there.
And that's it?
That's it. Even if you ask follow-up questions, even if you refine the prompt, it remains a localized, low-permission interaction.
Right.
It is not an automatically ongoing, connected workflow. It has no concept of tomorrow at 8:30 a.m.
Oh, interesting.
When you close the tab, the active processing stops.
The core lesson here, really the practical value for you listening, is to use the smallest permission set that solves today's tasks.
Yes.
Like if you only need to digest once, ordinary Gemini is the safer, lower friction choice.
Definitely.
It's like hiring a full-time, salaried executive assistant, giving them a desk and a corporate credit card, just because you wanted them to order you 1 cup of coffee.
Exactly.
Sometimes you didn't need to walk to the counter yourself.
I love that analogy because from an information security perspective, minimizing permissions reduces your attack surface.
Right.
If a tool doesn't have the ongoing permission to read your emails tomorrow, it cannot be manipulated into leaking them tomorrow.
Makes total sense.
It is always best practice to use a tool that fundamentally cannot do more than you need it to do.
But let's pivot sharply here.
Okay.
Because neither ordinary Gemini nor Gemini Spark is designed to natively run software test suites or compile massive code repositories.
No, definitely not.
I mean, Spark can write a script in a chat window, sure, but it can't execute it against your local database.
Right.
So if I'm a developer or I'm trying to automate infrastructure, where do we route those tasks?
That requires a completely different execution surface entirely. You need a repository or terminal surface.
Okay.
The viewer problem you face here is needing to make verifiable code changes with terminal and test proof.
Right, which Spark can't do.
No, a connected app workflow surface like Spark cannot safely provide that. You do not want a general executive assistant guessing at the syntax of your production code base.
No, you absolutely do not. One bad line of code and the whole app goes down.
Exactly. The proof artifact we use for the surface is a separate sanitized repository task.
What does that look like?
The prompt you would use looks like this. Quote, add a parser, run tests, and inspect the diff, unquote.
Okay, let's really unpack this mechanism. Because we are talking about a code base, an edit, a terminal execution, running a test suite, and a diff approval loop.
There's a lot going on there.
Yeah. How does this actually work? Let's start with Codex.
Okay, let's look at a verified local Codex toy repository subtask.
Right.
When you hand that prompt to Codex, it operates via a cloud sandbox. It actually clones your repository into an ephemeral, isolated container in the cloud.
Wait, ephemeral isolated container. Let's translate that for everyone. Sure.
It creates a temporary virtual computer on a server somewhere that only exists for the duration of this one task.
Oh, wow. Okay.
It copies your code into that temporary computer. It executes the task, writing the parser and running the tests inside that bubble.
So it's totally separated from your real machine.
Exactly. Then it returns an asynchronous pull request, or PR, containing the exact lines of code it wants to change for you to review.
Right.
It never actually touches your local machine's file system directly during execution.
Right.
Once the PR is generated, that temporary cloud computer is completely destroyed.
Okay, so that's the Codex flow. What about Claude code?
Well,
And just to be crystal clear to everyone listening, we are not inventing a Claude code run here today.
no, we are not.
We have not live tested this for the show.
Yeah.
We are describing it strictly from Anthropic's official documentation as a comparable coding agent surface, and you will have to verify your own access to it.
Understood. So according to the official Anthropic documentation, Claude Code is a synchronous coding agent surface that lives directly in your local terminal.
Oh, so it's right on your machine.
Yes. It doesn't clone your repo to a cloud server. It works right where your code lives locally.
How does it know what to do?
It utilizes a specific file called a claudeued.md file, which sits right in your project directory.
Ah, okay.
This file acts as project memory and sets the rules for the agent. Claude Code reads your local files, it runs the shell commands you allow it to run, and it proposes edits right there in your interactive command line session.
So if I connect this back to our earlier analogies,
Okay, let's hear it.
Codex is like sending an intern to work from home.
Yes.
You give them access to the code repo, they do the assignment on their own computer, and you wait for them to send you their final report as a pull request.
Exactly.
You check their work before merging it. While Claude Code is like having a senior engineer sitting right at your keyboard pair programming with you in real time.
That is an excellent way to visualize the architectural difference.
Yeah.
Codex is an asynchronous handoff architecture. Claude Code is a synchronous pair programmer architecture.
Right.
But despite that massive difference in where the work happens, cloud versus local, they share the same crucial architectural loop. Plan, act, observe, and verify.
Ah, verify.
Yes. Both fundamentally require you, the user, to inspect the final code diff before accepting it into your main project.
Which really highlights a common thread running through this entire deep dive.
It does.
Whether it's an email digest from Gemini Spark, an answer from ordinary Gemini, or a code pull request from Codex, the final step is always verification.
Always.
You cannot just blindly trust the output.
And that is the most critical hurdle users face today.
Pretty huge viewer problem.
It's massive. Blindly trusting AI outputs leads to disastrous consequences. We are talking about leaked credentials, hallucinated financial data, and completely broken code bases.
The horror stories are literally everywhere.
They really are.
People submitting legal briefs with fake case law because they didn't verify the AI's output.
The mechanism to prevent this relies on strict rules for verification, and those rules change based on the tool you used.
Let's break them down by surface.
Okay. If you are generating cited digests like our weekday brief, you must demand verifiable URLs and dates, and you must physically click them to verify they were read exactly from the source, not hallucinated by the model's training data.
Right, because these models are people pleasers.
They are.
They're basically prediction engines. If they know a URL should look a certain way, they will invent a URL that looks perfectly plausible if they can't find the real one.
Exactly. They generate what is statistically likely, not necessarily what is true. Now, if you are using connected actions like Gemini Spark accessing your Google Workspace, you must have a strict human review before execution.
The checkpoint.
Yes, you must read the drafted email before it sends.
Yeah.
Finally, if you are using coding agents like Codex or Claude code, your verification must be inspecting the actual code diff line by line and running the repository's tests yourself to ensure it behaves as expected.
So just compiling isn't enough.
No, compiling is not enough. It has to pass the logic tests.
Okay, I need to state an absolute rule here. I want everyone listening to hear this loud and clear.
Go for it.
You must never paste passwords, payment data, API keys, private emails, client files, or sensitive documents into any of these tools.
Never.
I don't care if it's an answer surface, a workflow surface, or a terminal surface. Just do not do it.
That is completely non-negotiable.
Right.
And this raises an important, deeper note about how these tools are built to handle data. What truly determines the right tool is a combination of work location, permission boundaries, task recurrence, and the type of proof required.
Okay, unpack that a bit.
For instance, Claude Code relies on OS-level bubble wrap sandboxing on Linux, or a framework called Seatbelt on Mac, to restrict what the process can do locally.
Right.
Codex relies on a cloud sandbox, meaning it's completely isolated from your local environment, but requires your code to actually leave your machine.
Okay, stop right there. OS level bubble wrap sandboxing.
Yeah.
That sounds incredibly safe. It sounds like my computer is wrapping the AI in packing material so it can't break anything.
It's the marketing, yeah.
If a tool says it has a sandbox, doesn't that automatically mean I'm safe to let it do what it wants?
It is a very dangerous trap to fall into. Platform trust is not the same thing as technical isolation.
Oh, wow. Okay.
Let me explain what Bubble Wrap actually does. On Linux, Bubble Wrap is a tool that uses kernel features to create an unprivileged sandbox.
Okay.
It essentially lies to the program running inside it, making the program think it has its own file system and its own user space, while actually restricting its access to the real host operating system.
Okay, so it isolates the AI's workspace. That sounds good.
It is good for protecting your operating system files. A sandbox might protect your local hard drive from being completely wiped by a rogue script.
Right, which is important.
But it doesn't protect you if you accidentally paste your AWS production keys into the prompt.
Because you literally handed them over.
Exactly. The AI still has access to the text you gave it, and it certainly doesn't protect you from the agent writing a perfectly compiling piece of code that introduces a massive security vulnerability like a SQL injection flaw into your application.
Wow. Okay. That is terrifying.
You must verify the proof artifacts yourself. The sandbox protects the environment. You must protect the outcome.
That is a phenomenal distinction.
Thanks.
The sandbox protects the environment, you protect the outcome. No matter how much bubble wrap they use, you still have to read the diff.
Always read the diff.
So let's bring all these rules, all these different surfaces together into a single, easy-to-use checklist for your next task.
Let's do it.
We want to solve that moment of freezing when you look at a blank screen, completely unsure which tool to open for the task at hand.
We can provide a definitive, reusable routing checklist right now.
Okay, if your task requires a one-off explanation, a quick brainstorm, or a single text output,
you route that to ordinary Gemini.
if your task is a recurring, connected workflow that needs to run in the background, gather data across apps, and is gated by your approval,
you route that to Gemini Spark provided your account is eligible based on those strict criteria we discussed.
and if your task is a repository change that requires terminal access, running tests, and generating a code diff as proof,
You route that to Codex or Claude code, depending on whether you prefer the async cloud handoff or the synchronous local pair programmer.
right?
But before you do any of this, there is a critical starting step.
What's that?
Always start with a dummy file or a toy repository before introducing real data or live schedules.
Yes, exactly. I mean, you wouldn't test drive a brand new sports car by entering the Indy 500.
No, you wouldn't.
You don't know how the steering feels. You don't know how the brakes respond. You start in an empty parking lot.
Exactly. Testing the boundary of a schedule or seeing how an agent edits a code file in a safe, sanitized environment is the only way to truly understand how the agent behaves without risking your actual assets.
You have to learn its quirks.
You have to learn its quirks before you trust it with your real work.
Okay, before we wrap this up, I want to pose something for you, the listener, to mull over.
Okay.
We are talking about building incredibly secure, sandboxed environments where AI agents handle our routine coding updates and our daily email digests.
Right.
If these tools successfully automate all the entry-level tasks, gathering the news, writing the boilerplate parsers, how do we train the next generation of senior engineers and managers?
That is a great question.
Right. If the AI is doing the junior work in a sandbox, where do humans get their practice? It is something we are going to have to grapple with very soon.
It is a profound structural question for the future of work.
It really is.
But for today, focusing on your immediate tasks, I have exactly 3 takeaways for you.
All right, let's hear them.
Number 1, choose by where the work lives and what proof it needs, not by the newest name. Number 2, Spark is an eligibility-dependent connected workflow surface. Ordinary Gemini is often the safer one-off start. Number 3, Codex and Claude code fit when repository, terminal, diff, and test verification are central.
This is AI Everyday Lab-like. Subscribe, share, and turn on the bell to route your next task right.